Can you tell us more about Victor and the way it builds automation tools? Like, how does this one fit into engineers' tool pocket?
The principle of our platform is that we make it as easy as possible for an engineer to automate these kind of workflows. It's a web-based platform. And basically on Victor, you can make custom web applications. So one thing is about building an interface. At the end, you don't want, let's say, automation shouldn't be just a script that runs. At the end, you want to present all kinds of insights, right? So in the interface in Victor, you can
What if you could dramatically speed up structural engineering work without sacrificing accuracy or creativity? Many firms still think automation means losing control or settling for cookie-cutter designs, but new AI-driven tools are proving the opposite. They're changing how engineers approach complex design problems and reshape the very definition of efficiency. Today, we're joined by Stijn Jansen, Chief Product Officer at Victor. With a background in aerospace engineering and deep expertise in parametric design and knowledge-based engineering, Stijn is helping engineers automate design processes to work faster, better, and with more enjoyment. In this episode, we'll talk about Victor's AI Builder, the evolving landscape of engineering automation workflows, and how teams can balance customization with efficiency to stay ahead of the curve. If you're a structural engineer or AEC leader looking to embrace automation without losing your unique design edge, you won't want to miss this conversation. It's packed with insights you can use to make your projects more efficient and your engineering practice future ready. But before we jump in, I wanted to tell you about our AEC PM Connect event, where emerging and experienced leaders can learn about real-world strategies to drive performance, empower teams, and lead with purpose. Our next event will be on June 10th, 2026 at the Forest Gate Country Club in New Jersey. Visit aecpmconnect.com and register today. I'm your host, Matt Picardal, and this is the Structural Engineering Channel. Stijn, can you tell our listeners a bit about yourself and how you got started in engineering and product development and what eventually led you to your role at Victor?
Yep. Well, definitely, Matt. Yeah, so basically I have a background in aerospace engineering. So I studied so I'm from the Netherlands, studied in Delft. So that's the biggest technical university that we have in the Netherlands. So I studied aerospace engineering. And then during my studies, I also got really enthusiastic or passionate about programming. So I did some courses during my studies, and then during my master's degree. So you have in aerospace engineering, you of course have these different disciplines like aerodynamics or structures or your whole control and systems. But there was one direction which was really focused on, okay, how can you actually bring all these disciplines together to come up with design? Because at the end, right, as with, I think, a lot of structures, design is a compromise between different disciplines, right? So let's say an aircraft is not, or the wing of an aircraft is a compromise between the optimal aerodynamic shape and structural shape. And then there we basically used programming and automation to solve these kind of design challenges. So and it was called their knowledge-based engineering. So how can you basically integrate the analysis of these different disciplines to, basically come up with optimal design. So it's sort of in the generative design space. So and that really fascinated me. So I still remember well when you sort of were running, in principle, just running code still fascinates me, right? You write some code, you run it, computers are incredibly fast, of course, and then something comes out, and then running the first optimization routines and then seeing sort of the shape of a wing change until it sort of finds an optimum. I found that really fascinating. So the combination, then I think I got really hooked to the combination of engineering with software or programming. And then I joined a small company. So this was in 2013, which was just founded also by two other engineers. And at that moment, we did a couple of things, but one of the things we also did was quite a lot of structural engineering in the offshore industry. So we were doing projects on like big steel structures, fatigue analysis. And also there was a lot of repetition. And because we just were a bunch of young engineers who also really like to program, we basically just started to automate our work. So then that became really our focus, because we noticed that was not, let's say, the standard in the industry. So there again, we really started to automate engineering work by programming. And that's what we, at some point, we did some of these projects for customers. Then we really saw, okay, there's a really big opportunity here. So let's make a product out of this. And then we started to develop VIKTOR at that moment. So that's sort of a bit of the story. And then, of course, throughout the years, a lot happened. But this is the short summary, let's say.
Yeah. No, that's fascinating. Like, so how does your expertise in all of these disciplines, aerospace, geotechnical, structural, offshore engineering as well, how has that influenced the way you design these automation solutions for these projects?
Yeah. Yeah, so I think what was quite interesting to see is that I think what's a bit of a difference. There are I think some similarities and some differences in these industries. So let's say similarities are, as I already mentioned, right? So if you look at an aircraft, or you design a building or a bridge or an offshore structure, at the end, it's about finding the optimal design. Basically, it's something across multiple disciplines. So that's, I think, something that either if you're designing a building and you're looking for, I don't know, you have all your MEP systems in there as well, and also your structural shape, but also, of course, the architect has a certain idea about how a building should look like. So I think that's really similar to then if you want to design an aircraft. What is, I think, a very big difference, and that's also noticing when I became more active in more the AEC and the civil industry, is the uniqueness of the projects. And let's say you are at the end, a building or a bridge, that's something that you sort of design and is built once. Typically, there is, of course, let's say to generalize it a little bit. While if you look at an aircraft or a car, basically, you have a lot of it's a bigger series thing. So that also means that optimizing the business case for optimizing the design is a lot more interesting often. And I think for more unique projects, that's something in the civil industry, for example, which is more challenging. Next to the fact that you have often another project team, like as you have some contractor and engineering firm. It's sort of a group that comes together. So I think in general, there are a lot of reasons why in the AEC and civil industry, also this digitalization, that's also what you see, right, is quite low compared to other industries, because it's such a typical industry with unique projects.
Yeah, that's something that I've noticed, as I work in the AEC industry. These are essentially massive projects or big projects compared to, I guess, the scale of maybe an aircraft, right? So we obviously have all these different disciplines: mechanical, electrical, plumbing, architect, structural, and everything needs to be coordinated too. So we're not just like under one umbrella most of the time, and we can't just press one button and it designs everything. Like I know on the structural end, we try to automate as much as we can, right? And then but something's going to change. Like there's going to be an electrical, or there's going to be a change in the design, and then in our end, we try to automate that as much as possible. But it'd be great if there could just be like one button that designs the whole building. But it's so unique for every project. It's I think that's one of the like you were mentioning. It's I think digitization is a little lower on the AEC side. I think because of those points that you mentioned, they're so unique, and there's a lot of multidisciplines in there.
Yeah, indeed. And I think indeed also what you're saying, and that's really recognizable, the fact that it is super multidisciplinary, but also it all takes place in parallel, right? So it's not that, okay, let's say structure is finished, then electrical does its thing, and then the next sort of discipline, and then the next one, and sort of it's this linear process. because at the end what's happening is that in parallel every discipline is basically sort of designing, while also often still things change along the way, right? Maybe requirements change and etc. So you are with and then there's a lot of a lot of dependencies interrelated as well between the disciplines. So when something structurally changes, that I don't know, a beam becomes bigger, that also has impact on all your HVAC systems. So so the fact that you indeed have this parallel process with all these disciplines with a lot of connections, then so what we see as the only way to really make a big leap forward is when you start to also integrate, or let's say have automation between these disciplines in place.
Is that how, just from your aerospace background, is that kind of how it works too in terms of multidiscipline, or is it usually just like one design that just goes, or is like the structural from making a plane waiting on the electrical to finish their components? I'm just curious about how that kind of works.
Yeah, so well, I've never worked in the aerospace industry, but I have, of course, some friends who work in that industry, and I think, let's say, so the thing that we were working on, for example, at the university at that moment, was literally the holy grail that we were working towards. Was how can you indeed, with one push of the button, based on requirements, so basically that you say, okay, I have an aircraft which can, with this range and these amount of people that I want to carry, just one push of the button, come up with the optimal design, and that it starts to see what kind of maybe even type of aircraft and everything basically combined. And I think still that's a very nice vision to work towards, right?
It's a dream.
Which you can, I think,
would be nice.
Yeah, that's the dream. And I know, for example, that's also quite interesting, because I think we can also learn a lot from some software development, right? Because so what's happening in software development also there, if you look at big software products, also a lot of people are basically working at the same time on the same software product. So I know, for example, from a friend of mine who works at SpaceX, that they also set up their design system. So let's say their engineering basically also in this same way, where they said, okay, we just have basically one central database, and that everybody is sort of pulling and pushing and branching from that design on his own discipline. And I think that's an example where also in terms of automation and doing that in a very modern and digitized way, they're really far with that.
Yeah, that's a good point. Even just the multidisciplinary interactions with each other, like there could definitely be space for improvement there in different industries like AEC.
Yeah.
From your perspective, Stijn, what are the key steps or in creating an effective automation workflow, like the balance, speed, accuracy, usability? Like, what do you need? Like, what's the formula for that to do something that's really effective?
Yeah, so I think there are a few things I think that are necessary. So first of all is some kind of standardization. So basically, I think what's now often the case is that as an engineer, you have a lot of, let's say, knowledge in your head, right? And you sort of along the way make certain decisions. I don't know. And so I see in a certain analysis that I do, I see this, okay, then I make the decision to maybe go for this design solution. So I think one thing, if you want to go towards automation, it's really about getting all that logic, basically get that out of the heads of people and see how you can build that logic into software. And maybe that sounds sort of scary in the way of, okay, are we sort of replacing humans? But I don't think it's, what I noticed actually is that actually people really, that this process is very also pleasant to go through as an engineer, because it's really about, okay, what are we now actually exactly doing, and sort of writing that down. And then when you want to automate, you're sort of forcing yourself to really standardize such a process. And so I think that's sort of step one, becoming really explicit about, okay, how is it actually, what choices are we actually making, etc., and how is this going? That's, I think, a very important first step. Then, once sort of that is defined, then I think it's also really important to look at, where I think to look at it, I think really in a bit of a business sense. Maybe that's something that as engineers we can also sometimes learn from. I think
Oh yeah.
automation is at the end, it's what do? You invest a certain amount of time into automating something. And then the question is, okay, what do we reach with that, right? So let's say, we automate this design process. How much time do we save then? And how often do we then go through this process? And I think looking at it really at that way forces you to think about, okay, what's our, let's say, smartest investment to automate first? And that sometimes those can be really sort of simple tools in which you have some repetitive work that you just automate. But I don't know, reporting, stuff like that, right? That's sort of
Oh yeah.
the work that as an engineer something changes and then you have to update your report and then you're copy pasting stuff, and then that's not what we are as humans, I think, very good at. So I think thinking then about looking at this process, then thinking, okay, where should we start? And then I think you can step by step in that way further and further automate. Because I think indeed what the risk is when you just say, okay, where we want to, I think it's good to have a vision, okay, one push of the button there, but then defining a path towards there based on, let's say, a business case. I think that's really important to look at it like that.
Yeah, it's like getting I think you mentioned, I have that flow chart in my head. I've seen some, at least in structural design, there's when we're doing some designs, there's sometimes like a flow chart, right? Where I think some of that is good for automation, and I think that's great, right? Automating design, and I know some engineers might be scared of that, but I think from my experience, there's always going to be a need for that engineering judgment, because once you press a button, it's not, at least in the AEC field, once you press a button, great, it can design it, but then when you get out into the field, something's going to go wrong or something's not going to show up unexpectedly, and you're still going to need an engineer to come up with some unique solutions that there's not an automated spreadsheet for. So
Definitely.
and the business sense too, right? You can spend a lot of your time just, if you need something designed quickly, you can do it quicker and provide a design quicker or a solution quicker to the team. Saves everyone money because you figured out a way to automate that.
Exactly. Yeah.
I wanted to talk more about VIKTOR. Can you tell us more about VIKTOR and the way it builds automation tools? Like, how does this one fit into engineers' tool pocket?
Yeah. So basically, with VIKTOR, we really tried to solve the problem that we have been talking about. So the principle of our platform is that we make it as easy as possible for an engineer to automate these kind of workflows. And how we do that is that it's a web-based platform. And basically on VIKTOR, you can make custom web applications. And in these applications, well, first of all, we have all kinds of building blocks in our platform to make these custom web apps. So one thing is about building an interface. At the end, you don't want, let's say, automation shouldn't be just a script that runs. At the end, you want to present all kinds of insights, right? So in the interface in VIKTOR, you can make sure that your tool isn't a black box. So you can show all kinds of visualizations of all kinds of results, but also maps, 3D visualizations. But also there's the possibility to input all kinds of information. So think about a bit more on the parametric design side. So you can just fill in all kinds of parameters, your geometrical parameters, but also all your requirements. So also, let's say, all the loads that you need, and load combinations and material properties. So, and that can either come that you fill it in basically in the interface of VIKTOR, or that you get it from another source. That could also be possible. So, and that you maybe upload an Excel sheet with your load combinations. That's also something which is possible. So that's one important factor. And then we offer all kinds of integrations that we have available. So basically, You can connect to finite element packages, to bin models, a whole range of typical engineering software with which you can integrate so that you can really automate this full process. And then in what you then can do, once you have created this app, you can then publish it in your own environment that you have as a company, and then give also your colleagues access to use these apps.
Yeah, very cool. I know that's something, at least in the structural engineering industry, there's engineers always complain about, oh, I got to redesign, or that's like one thing that I know that we don't enjoy doing. So it's if we could, there's ways to automate that. I think we could spend a lot of the time, doing more engineering instead of repeating tasks that we've already done before. I think that's the structural engineer's dream. It's not do reports and redo stuff.
Yeah, that's really what we stand for. Our slogan is automate the boring, engineer the awesome. So what we actually believe is that at the end, if you automate, what we see happening is that actually what you mainly do is you just really increase the speed of a design iteration. And that means that, well, indeed, when something changes and you have to redo your design, this just becomes a lot faster, which helps with making deadlines, making sure that your projects don't run over, etc. But also, once you have this iteration speed, when you increase that means that it's way more easy to optimize your design. So you can way more easy play around with, okay, what happens if, right? What happens if I sort of, I don't know, maybe you're optimizing, just to give an example, you have a floor with piles below it. What is actually, do I increase the spacing of my piles with the result that my floor gets thicker, or I need a steel reinforcement in my plate, or do I make the spacing less, resulting in more piles, but maybe shorter piles? And I think these are typical things that we are doing, right, as structural engineers. And I think the fact, if you automate this process and you can really quickly play around and try different variations, then that really helps you to simply save material or save the CO2 impact of your design, save costs. So it's often not that at the end what we see that, let's say, okay, now I automated the process, well, now my work is done, I can go to home. It's just that you really start to use these tools to actually create a lot more value as an engineer than what you were able to do before.
Yeah, and I think there's a lot of value in that, in terms of instead of spending all of your time on one design, you can go to the client and show them, we could do this option, or this option, and you did it in the same amount of time. But now you're giving the client different solutions that can benefit not just them, but the whole entire team can look at it, right? Because since there's so many disciplines, one option may be better than the other option for one discipline, but then that's where the conversation comes in. Now you have these different designs, so now the whole team can pick. That's what I noticed, when we're working with multidisciplines, having those options for the entire team to look at. Yeah, I think that's very valuable, instead of just, this is it, guys. It needs to be this way because that's the way we calced it. But with automation, we could do that. That's pretty cool.
Yeah, and often it's now the case when someone asks you, maybe someone comes with a good idea, but you're already close to the deadline. So, oh yeah, can't we change that? And then it's a good idea, but if I need to redo all these steps and this and this and this, don't have basically the time to check this out. And that's, of course, really a pity if that's the case. But I think this really happens very often. Yeah.
Yeah, some time crunch, and then it just takes time sometimes if you don't have your tools in place to come up with a new design or change it up.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
What are your thoughts on AI and automation, in terms of replacing human judgment? How do you position these technologies as tools to empower engineers rather than replace them?
Yeah. So I think this is indeed a very important topic, I think, because at the end, let's say AI, what we talk about now, of course, mainly at the moment is large language models. They are, by definition or in principle, non-deterministic, right? Or let's say probabilistic or whatever you call it. But basically, to put it simple, with the same output, you can get another, or with the same input, you can get another output. If you are creating text for marketing, that's okay. But if you are designing a bridge and it's sort of a probabilistic system where you don't know, it might have hallucinated. Well, I think that is in our discipline. That's just, let's say, that's just not possible. Basically, right? You cannot design a bridge without proving and having the confidence that it's aligned with all the norms and all the calculations. So, I think this is something that we need to figure out. Because we do see that AI systems can be really powerful as well. So I think there are multiple ways to cope with this. One thing is that it's basically had a process around it, right? So also people make mistakes. So if you ask, I don't know, a junior engineer to design something, then also that, or also I think senior engineers, everybody makes mistakes, right? So there's a process in place to make sure that, okay, maybe someone made a mistake. So we actually review this, and by having this process in place, we can have a quality assurance. So the same, I think, is something that you can do with AI, just seeing it as, making sure that you really have a good review process. So that's one thing. And the other thing, and that's more towards how we are now applying AI. So our platform is basically based on Python. So you write the logic in Python, and based on that, you can automate this whole workflow. So what we have recently developed is basically a tool with which you can generate this code based on prompting. So you can basically say, okay, create an app that does with which I can do this and this calculation, for example. Then it generates the Python code for you. The big advantage of that is that it saves you a lot of time, because at the end, as you said, right, you always have project pressure. So we often see that automation is not being done because you just have too strict deadlines. So we really aim to make, okay, how can we make it as quickly as possible for you to automate your work? And there we see that AI can really help with, okay, getting something quickly. But then what we are doing, so you use this large language model to actually create a deterministic tool, because at the end it's Python code, and there you know for sure, okay, with a certain set of input, I get the same output. So then you can just review that code, make sure that you have all the checks, and then once you then publish that app, then you know, okay, I can guarantee that this actually does what it should do.
Yeah, there's ways to check in terms of back checking it, quality assurance in terms of that. So it's not just, I don't know if it's right.
Yeah. And of course, I think it's something to be very aware of. So these large language models are, let's say, by design, they are non-deterministic, or that's let's say their strength, right? They can come up with new things or creative things. That also means that by design, you cannot fully avoid hallucination. Well, you don't know where it goes. Of course, there's a lot of research and development in there, and you don't know where this technology will be in a few years. But this is the current situation. That's something that we need to deal with.
Yeah, and I think something like that, in terms of, at least with the available like chat GPTs around, like, not deterministic, essentially meaning you can ask it to give you something. I don't know, maybe the size of a beam or how something works. You type that multiple times, or maybe in a different way, you're not going to get the same answer sometimes.
Exactly.
Or it hallucinates, like you were saying. Like it says something, but then you think about it, it's like, wait, that doesn't seem right.
Yeah.
But it's not there yet for the engineering design. But that's something that, as us engineers, we always have to, apply our engineering judgment on those.
Yeah.
For the future, what are you looking forward to in terms of trends? There's a lot of exciting things in the field. What are you most excited about?
Yeah. So what I'm really excited about is I think the combination of these large language models with more also deterministic tools. So a bit of these agentic workflows. So what you see is what you can also do is that, let's say that you let a large language model call a tool. That basically means that what you could do is that you say, okay, I have this calculation, maybe a beam calculation, let's call it like that, right? So you just have a simple beam calculation, or it can be a finite element analysis, whatever, let's say, but calculation that you trust. And then you let the large language model use that as a tool, basically. So it just knows, okay, I have to input some parameters and I get something out. About the future, I'm really excited about thinking about it in that way. So creating these agents, let's say a structural agent who can use certain tools, the tools that you have validated and verified, but who can really help with, you could see that, basically in going through this whole process, or that you can just ask, hey, what about if you try to do this? So really looking, I believe that in the future we will have agents basically sort of as colleagues in some way. And that can also be, I think, let's say a colleague being an let's say an intern in some way, for example, with a certain knowledge. And then the big question is, of course, how senior can these agents get? That's, I think, the big question. But that really excites me. So basically, how we can really use this technology, because at the end, right, we face massive challenges in the world at the moment.
Yeah.
Also, in terms of engineering, we hear from almost all customers that they are struggling to find enough engineers. So we have these huge challenges in which I think we as engineers can really play a big role, but we just don't have enough people. So if we should really think about, okay, how can we get ourselves more productive? Because I think then the impact that we can make as engineers can be just a lot bigger than we do at the moment.
Yes, needing one engineer doing multiple things because of the tools that he has at his disposal.
Yeah.
And I think that's pretty cool. That's so I'm picturing it in terms of Python is like deterministic, or a flowchart, right? Or combining that with the large language models, then that's when the large language models can actually be kind of that assistant. Hey, can you design this beam, or what's the optimal size of this floor, or XYZ?
Yeah.
Can kind of do that because it kind of has like the deterministic. It knows how to design in terms of flowcharts and whatnot. That's pretty cool. Yeah. And imagine having a assistant like that.
Yeah. And also that's also one of the other reasons is that, what's still the go-to tool usually for engineers at the moment? Well, we all use Excel, right?
Yep.
That's just feels a bit like, and of course, I think Excel, it's a super nice product, and it's a super powerful tool. However, if you look at it's, is it really the most logical tool to use for the things that we need to do as an engineer? And I think there are a few things that programming or Python enables. So one thing is, let's say, automating. If you want to run a finite element analysis. So what's super nice about currently that all these finite element analysis packages have APIs available with which from Python you can basically automate these processes, right? So everything that you do in the interface you can also do via Python. Well, that's super powerful. But and something that is, I think, from Excel doing that. Well, you can start doing stuff with VBA and etc. But I also did that quite a lot in the past. But I can really recommend to then, if you want to do these kind of steps as an engineer, then Python is, I think, a super powerful tool that you can have in your toolbox as a structure engineer. So, however, there's a learning curve, of course, right? And again, here we have the fact of, it's nice if people learned it in university, then you went already through this learning curve. But when you are just on your projects on a daily basis, it's very difficult to find the time to learn this new tool, although you know that it can probably help you a lot. So that's the other thing why we have developed also this app builder, how we call it, where you can go from a prompt to your tool. basically that you don't need to, it all works in the browser. So you don't need to install Python locally or whatever. You can just start prompting. It generates the Python code. And what you will notice as an engineer, engineers are typically people who can really grasp these kind of technical things easily. Then you start to see the code, and then Python is quite easy to read. You just see formulas basically. And in that way, we believe we can also really help engineers to start to get an introduction into code in a very easy way.
Yeah, that's really cool. It's like, I'm imagining it kind of like back in the day, if you wanted to build a website, you needed to know how to do HTML. But then now you just go to some website, is like, I want a website that looks like this. That's what it kind of feels like in terms of, well, that's what it needs, right? If you're an engineer that wants to do something, instead of learning Python, like just all Python, it could be overwhelming. You don't have time. But with tools like this, it could make it a lot more digestible and help you out in your calculations or whatnot. So it seems like that's the way the industry should be going in terms of you want to do automation, learn Python. Well, yeah, you should, but not. There's got to be tools to make it easier, right?
Yeah. So that's really what we are aiming for.
Really cool. My last question, Stijn, what's one final piece of advice you'd like to share with engineers or AEC leaders who want to adopt automation into their workflows?
I think one very important thing is to take some risk in that sense, right? Because and that's always, of course, scary, because it's always and logical. We already face enormous risks in the projects, right? That's typical also about the industry: low margins, high risks. And we often see that then you tend not to automate because it's seen as something different or innovative, and you say, okay, we've always been doing this process like this, let's just keep it like that. I think same has happened with other big innovations in the industry, like drawing from paper to AutoCAD. You also know, in the beginning, I was speaking to someone lately who an older engineer who said, in the beginning you had AutoCAD, the first version, and people were just quicker on paper still, and then people were very nervous. Okay, are we now going to do that, or from 2D to 3D, right? Those are the same things where you see that in our industry. It's typical that although 3D modeling was already around for a long time, still a lot was done in 2D because of this sort of, also risk mitigation. But I think now, we should, what I can really recommend is to just try it out, give it a try, start small, just say, okay, let's see if we can use maybe AI in some way or automate it in some way. We just invest a little bit of time in it, think about a clear case, and then go from there. But we really should do that, in my opinion, to at least give it a try and try to innovate.
Yeah, like you're saying, there might be people that think it's a risk, but instead of focusing on all the things that could go wrong, right? What if it works? Look at the future about all the projects, then, if you take a small risk and then it could lead to this, like that thing could save you X amount of dollars in the future if anything like that works. So I think that's great advice.
Yeah, dream big in that sense, right? I think that's really important. Yeah. To dare to dream big.
Yeah, it's really exciting.
Yeah.
Thanks so much, Stijn, for talking with me today. I think that's really cool to see how more of the practical side of things in terms of like how automation works and just talking about the future of the industry and our technologies like this. It's really exciting. So thanks so much for sharing.
Yeah, thanks a lot for the opportunity. I really enjoyed this talk. Time went quick, so that's always a good sign.
Yeah, absolutely. Thanks, Stijn.
Okay, thank you, Matt.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.